Okay, so we're recording now. All right, so you can move things around from one side of the equation to the other by using the opposite operation. Okay, when you want to move an entire term, just change the sign to the other side. When you want to get rid of some coefficient, it's called a coefficient, you do it by using the opposite operation. Multiply, you divide. If it's divided, you multiply. So here this means that x equals negative 10 divided by 2, which is negative 5. Yes? And then of course, what we always say here is that if we put this number back here, we should get it to stay. Okay? So when something simple like this, you don't do this, but if you're not sure whether you have the correct answer or not, you can always check. What does it mean to check? Go to the original statement and then plug in your number, and then the question is, replace the variable by your number, and the question is, will this equal 0? And you compute, you do get negative 10 plus 10, this equal to 0. So we're good. Okay? All right, good. So this right here is what we call a linear equation, and I kind of already explained how to solve a linear equation. So once you have something like this equals to a number, pretty easy how to do, right? Just move the term that doesn't have an x to the other side and then get rid of the coefficient. All right, so let me define this. So definition, a linear equation is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers and a is not equal to 0. Because if a is 0, then there's no x, and then we don't have any equation here. Okay? All right. So that's what a linear equation is. So notice that I said here that can be written in this form. In other words, not every equation looks like this. But after doing some modifications, you may write it in this form. That qualifies as a linear equation. I'll give you some examples. So for example, is this linear? Is this equation linear? And the equation is 5 times x plus 5 minus 15 equals 3x. But let's see, something like this. Is this a linear equation? But let's see, the first and the quick thing that you can do is make sure that it has, we're not going to be worrying about two variables for now. Next chapter, there will be two variables involved, but just one variable is the y, which is dependent, so it will be always on one side. So you don't have to worry about two variables. Just make sure that there's one variable, and the variable itself has no power, nothing weird going on, like square root or something like that. If the variable appears alone like this, then it will be linear. Okay? Now, if you want to stick to the definition, this is linear, meaning that we should be able to write this in this form. Okay? So let's practice. Let's do this. So to be able to do that, notice that first here we can eliminate this parentheses, right? It's given in the 5. So multiply. So this would be 5x plus 25 minus 15 equals 3x. Everybody okay with this? Now combine like terms. So this would be 5x, then 25 minus 15. You cannot combine these guys with this one because they don't have an x. Okay? I give you 10. And this is not quite the form as above. So the last thing that we need to do is, let's bring this guy over here. Okay? So remember, you can move things around. So this term 3x, we can move it to the left. How? Subtract, right? We bring it here negative. So you can do, I'm kind of showing all the steps now, but at some point, I'm not gonna show all of these little steps. So we just brought over here subtracting, and now we combine like terms again. This one we don't touch it, but then 5x and 3x, we call them like terms because they both have the same variable part, the same literal part. So you do 5 minus 3, which is 2. So you get 2x plus 10 equals 0. And now this fits the form in the definition, right? A number times x plus a number equal to 0. So the answer is yes. But again, you don't really need to do all of this to be able to answer yes. As I said, just take a quick look. If the variable that shows up in the top with nothing going on, no power, then it's linear. Okay? That's a quick way. By the way, notice that equation, the same equation may show up in different ways. Notice that this was the equation that we started with, 2x plus 10. But that equation may show up like this. Okay? Many other forms. Okay? But the solution is still the same. What's the solution to this? -5. But this equation is the same as this one. Do you understand? And in fact, if you want to solve this equation, this is what you do. You write it in this. This is the simplest way that you can write it. And then it's very easy. Once you have it like this, it's very easy to solve for x. Right? Move this number over here and divide. Okay. All right. Questions about what a linear equation is? Okay, so then let's do examples. So examples, solve. Let's see, I'll do 3 times. And by the way, the variable doesn't have to be x, okay? So this is an A and this is a 9, okay? So sometimes the A and the 9 may look similar. Just make sure that you see the distinction. So let me write all the examples here. Okay. Let's do it. Okay, so I'm gonna go ahead. I'm gonna do number 1, and then I'll let you do 2, 3, and 4 in your own. Okay, but let me do number 1 so you get used to the general procedure. Okay, so solution. All right, so for number 1, we have 3 times 7a plus 5 minus 19 equals 2a minus 9. So our job is to solve for a. Okay, we want to figure out what a is equal to. So this is true. Now, there are many ways to do problems. I'm going to give you an advice. My advice to you is the following. The first thing that you should do is, instead of moving things around, okay, just simplify each side of the equation as much as you can. Okay? So in other words, for example, the right-hand side, there's really nothing we can do, right? It's already as simple as it gets. But there's some stuff going on here on the left. So work here and write it in this form. A number times the variable plus or minus the number. Once you have it like that, then you can start moving things around. Okay? So let's do that first. I'm gonna worry about the left. And on the left, the first thing that we do is we get rid of these parentheses. So we get 21a plus 15 minus 19 equals 2a minus 9. Yes? All right, so now we keep looking. Is there anything that we can combine here? Yes, we have these two guys that are like terms, so we can combine them. 15 minus 19. So that's -4. And that's equal to 2a minus 9. So at this point, we already are done simplifying each side. There's nothing more we can do. It's time to start moving things around. Okay? Now, instead of bringing everything over here, because we know that then we're going to start sending stuff to the other side anyways, what we should do is we want to solve for a. So the variable that you care about, which is a, collect all of the terms with that variable on one side, and whatever doesn't have a, send it to the other side. In other words, this guy, I'm going to bring it over here, and this guy, I'm going to push it over there. You understand this? And remember, you're allowed to move things around. So the 2a, I bring it here negative, and then -4, I bring it over here positive. Don't move things around, just change the sign. Now, combine. So we get 21 minus 2? 19. So that's 19a equals, what is this? -5. So what is A? Negative 5 over 19. 19 is multiplying, then you divide. Do you understand this? You can. This is general starter. You can do this. I mean, a linear equation is not going to get more complicated than something like this. Or it could. There could be fractions in here. But once we see the fractions, you're going to see how to deal with that. But other than that, it's just the same thing. Okay? Simplify each side, and then you start moving things around to solve for the Okay. Questions? No? All right. So go ahead and try the next three, 2, 3, and 4. So if you have a hard time seeing this, maybe you may want to sit in the front. Are you okay? Okay. Because I don't want you to be straining yourself. Okay. Is it too small? So sometimes when there are many parentheses, like number 2, like two pair of parentheses, sometimes we use different symbols like brackets and so on, but they all mean the same thing. Okay? I put parentheses, but sometimes you see like brackets here and then parentheses, so you get different symbols, but the same thing. It's just to group stuff. Okay, anybody has an answer for number 2? Yes? X equals -7. Is everybody getting the same thing? Yes? Okay, good. So let's see. Once again, if you want to check, just plug it in, right? But let me just do it quickly. Since everybody got the same thing, then you can do it quicker. So let's see. So, just be careful. There is a negative here when you distribute these parentheses, okay? So I would recommend when you have something like this, start from the inside. So, there are two parentheses here. Let's clean up the inside of these parentheses first before I distribute it, okay? Just to organize yourself. So I'm going to clean this up first. So I distribute the -2, so we get -6x minus 10. Now in here, we can combine like terms. So that's -4x minus 10. And now we can get rid of the parentheses, -ax minus 20. So far, so good. So notice that at this point, we are in a similar situation that we were at before. So what do we do now? X to one side, numbers that do not have x's to the other side. So I'm going to add 5x and add 20 to the other side. So we can do it in one shot. If we add 5x, what do we get to the left? -8 plus 5? -3x. And if we add 20 on the other side, what do we get? 21. Everybody understand what happened here? And now we divide. So 21 divided by -3, which is -7. So if you trust your work and your process, there's really no need to go back and check, okay? But if you're really unsure of something, then you should go and check. But you know, if you trust what you did, then it should be fine. Are you okay? All right. So it's good. How about number 3? Yes.
All real numbers.
Very good. So let's see what happened to you when you were solving this equation. So how do you know there's all real numbers? First of all, what does that mean? What does all real numbers mean?
It means that if you plug any number in, the solution is true. It's correct.
Very good. And how can you identify this?
Whenever the number on one side equals the number on the other side. Now when you have like a very, it's hard to explain. Like whenever it's like 9 equals 9.
Exactly. So it could be that when you're solving this, it could be that, for example, in the previous example, the variable never disappeared, right? After you simplify everything, you were able to have your variable equal to something. But now it could be that as you're doing these things, you get something on the right and something on the left, and they happen to be the same thing. So they will cancel each other out when you move it to the corresponding side. So your variable is gone. If your variable is gone, then you will only be left with numbers in your equation, right? And two things can happen. Either the numbers on the left match the numbers on the right, or they don't. Yes? When the numbers match, you have something that's always true. That means that's an identity. Okay? Like 2 equals 2, 9 equals 9. That's something that's always true. So what that's telling you is that regardless of x, that process will always happen and you will end up with something that's true all the time. So we will say that the answer is whatever you want, any number. In other words, all real number. Now, the other side of the coin is that you could get two numbers that don't match, like 3 equals 4, or stuff like that. That's a contradiction, something that doesn't make sense, something that's always false. In that case, we say there is no solution. You understand this? So when you're solving an equation, 3 things can happen. A linear equation, 3 things can happen. You either get one solution, or you get all real numbers, which is infinitely many solutions, or you have no solution. Yes? In the case of having at least one solution, we say that the equation is consistent. When there's no solution, we say the equation is inconsistent. Okay? All right. So let me write what I just said and also work out those two. So let's see. What did you get for number 4?
No solution.
Very good. So here is all real numbers. Now there are different ways to say this. You can just write the word all real numbers, okay? Or you can write like a bold-face R, as a symbol for the real numbers. And once we talk about inequalities, another way to write this is like this. Okay? So that's entire real line from negative infinity to positive infinity. Okay? Or in your case, negative infinity to positive infinity. All right? And in the case of no solution, so no solution, then you can write this as the classmate is saying, the empty set. This is one symbol. Another symbol that we use for the empty set is a pair of curly braces. Usually when you see curly braces, what we're saying is we're talking about a set. The set is just a collection of elements. And then if you don't put anything inside, what we're saying is that this is the set that has nothing. So it's the empty set. Okay? So the solution set is empty. There is no number that belongs here. And since I'm talking about this, when there is a solution, you can write it x equals -7, or you can say, okay, the solution set is the set containing one element. What element? -7. Okay? So different ways you can write a solution. Okay, very good. So let's see. Do number 3 over here. +1 equals 4x plus 9. So again, same idea, the simplify each side first. So 4x plus 8 plus 1 equals 4x plus 9. Then combine. And for example, already at this point, you can already suspect that, what's going on. The left is identical to the right. Yes? I mean, of course, x can be whatever you want. These two things will always be the same, regardless. Okay? So at this point, you can already deduce that it's all real numbers. But anyways, these guys simplify because when you move the 4x to the side, they cancel. and then you're done with 9 equals 9, but you could also say that the 9 simplify as well, if you move them, right? So you end up with the statement 0 equals to 0, or 9 equals to 9, whatever you like. And the point is that this is always true. Okay, so that's how you know that the solution is all real numbers. Are you okay? All right, good. And again, no solution, which the one that we're about to do is same sort of stuff is going to happen. It's just that, let's say that it would be 4x plus 9 equals 4x plus 3. Something like that happens, then the x's are gone, but then you end up with 9 equals 3. That doesn't make sense. That's why you know that there's no solution. Okay? So, two minus 15x. So that would be 6 minus 15x. So that would be, what is this, 7? 7 minus 15x equals 2 minus 15x. Once again, notice that the same term with the same sign and everything is showing up on both sides. That means they cancel each other. When you move the negative 15 over here, it comes positive. You're going to cancel it. So x's are gone. But now we are left with the statement 7 equals 2. This doesn't make sense. Okay? So this is false. This is what we call a contradiction. Okay? So what this means is that there is no solution. There is no x that you can put here that will make this a true step. Okay? All right, good. So, remark, when solving an equation, when solving a linear equation, 3 things can happen. Or I should say one of 3 things can happen. So one of 3 things can happen. So first is only one solution, okay? So only one solution. Or infinitely many solutions, in other words, all real numbers. So infinitely many solutions, that is all real numbers. Or the other possibility is that we have no solution whatsoever. Okay? So in cases 1 or 2, if you have either 1 or infinitely many, so at least one solution, we say the equation is consistent. So the equation is consistent. That's a classification, if you will, in defining this word. That's what it means to say that it's consistent. And in case number 3, we say the equation is inconsistent. Okay? That's a language that you may use. Somebody tells you, oh, that equation is inconsistent. That's a fancy way of telling you that equation has no solution.